All right, this lesson is one of the most important lessons in all of algebra, and it talks about slope and its and rate of change, which is a relationship between two quantities, and that's really all that slope and rate of change are, is a relationship between a specific relationship between two quantities. So today you'll learn how to create and calculate rates of change or slope from a few different representations, and you can find the rate of change from a graph or from 2 points. So I want to start us with a warm-up real quick. If you would just pause the video and try and fill in the missing blanks for these 6 different activities. Some are really easy and some are more challenging. Spend about 3 minutes trying to figure them out and return to this video when you're done. All right, hopefully you've had a chance to pause the video and try these out. There are a few of them, and they're just kind of interesting. So 6, blank, 12, 15. It looks like they're going up in increments of 3. So 3, so 6, 9. So it goes plus 3, and then plus 3, and then plus 3. So then 2, 6, 18. How is that moving up? So 2 times, or 2 plus, so plus pattern doesn't work, but times seems to work. So times 3. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. That's a times 3 pattern. All right, 11, 5, blank, negative 7. It looks like I'm subtracting 6 maybe. Minus 6. 11 minus 6 is 5. 5 minus 6 is negative 1. Negative 1. Oh, yep, that seems to work. And the next one, 2, 7, 4, 9. So it's going up and back down. So 2 plus 5. 2 plus 5 is 7. 4 plus 5 is 9. Okay, so it looks like we've got a plus 5 and then another plus 5, and then it looks like we're subtracting 3. So maybe this pattern stays still, and maybe there's a different pattern. This is just so happens to be the pattern that I came up with. My minus 3 would make it 6, and that I suppose would continue. 1, blank, 9, 16. This could be tricky. Here's one pattern that I noticed, is that I am adding 7 to this, and if I kind of do plus 5, I suppose that I could do plus 3, and that would make this 3. So 1 plus 3, nope, I guess that doesn't work, does it? All right, so we're going to try again, because that didn't work. So I made a mistake. It's okay. 1 times 1 is 1. 3 times 3 is 9. 4 times 4 is 6. So this 2 times 2 would be 4. Okay. Oh, I guess that did work. So plus 3, plus 5, plus 7. I guess that did work. All right, this last one looks a little tricky. It looks like I'm going in half. So 2 divided by 2, divided by 2, cut in half. Half of 1 is 1/2. Half of a half is a fourth, so $1/2, half of a half, divided by 2. Okay, so there's my pattern. Kind of tricky. They're all kind of fun. I hope you enjoyed this. So this is another patterns task, and I'm really going to just encourage you. Some of these are a little bit more straightforward than the last one, but what patterns do you notice in the picture? And I'd like you to just quickly pause the video and describe them in writing. And writing is a tool that helps us understand what we're thinking. If we don't have good ideas, then we can't write them down. And if we can't write them down, it means our ideas are not quite solid enough yet. And so get to the point where you can write down what pattern you notice. So a student in one of my classes said, so from pile 1 to pile 2, all of these are new. So it's a plus 4 pattern. So if I go over, it's a plus 4. And then if I go again to the next one, again, the bottom row is what's new. So the bottom row is what's new, and it's just another 4 being added. And so we got this plus 4 pattern going on there. So if I were to write this down, each pile adds 4 blocks to the bottom row. And so that's a nice way of describing it. Hopefully you noticed that we could also do this kind of like low school and count them out. And I see 1, 2, 3, 4, 5, 6 boxes. So there's 6 blocks. 6 plus 4 is 10, so there's 10 blocks, and I can confirm 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus another 4 blocks is 14, and again I can confirm 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and it seems to hold true. So this is one of those patterns that's linear, and it has a consistently growing pattern shape to it. So for every pile I go up by 4 blocks, and that is a relationship between two quantities that represents a rate of change or a slope. So we're going to really talk about 4 different representations. We're not going to talk so much about words today, but I guess you could. But by the end of this unit, you should be able to move from words to graphs, and from words to equations, and from equations back to words, and from words to tables, and from tables back to words, and from tables to graphs, and from graphs back to tables, and equations. You should be able to make a graph, and from a graph you should be able to write an equation, and from an equation you should be able to make a table, and from a table you should be able to make an equation. So there's all of these relationships between all of these different ideas, these 4 relationships. There's 1, 2, 3, 4, 5, 6 relationships between these 4 big ideas. And they go backwards and forwards, and by the end of this unit you should be able to get there. Today we're really going to be focusing on table values and functions in terms of linear slope and rate of change. So what is linear? A linear function are those which have a constant adding or subtracting relationship. And so notice in these 2 examples, as x goes up by 1, y goes down by 1. So this is a constant subtracting relationship. As x goes up by 1, y goes down by 1. And if I look at the whole table, you will see that it is very, very consistent. X goes up by 1, y goes down by 1. And this relationship is functional, it is linear, because it is a constant adding and subtracting, and it happens the same every time. That relationship is the same. Whereas if I look at number 2 here, take a look. As x goes up by 1, my y goes down by 2. Now, is that okay for now? Yeah, absolutely, it's fine. But when we check this second one, my x goes up by 1, my y only goes down by 1. No longer is it linear, because for the same movement here, it has a different movement here. So I'm going to label this not linear, because it does not have that constant adding or subtracting relationship. Whereas this first one is linear, because it does have that constant adding and subtracting relationship. So what is slope? Slope is defined in a few different ways. The one that we see the most common in everyday life is speed. So the car when your car is traveling down the road, you see 35 miles an hour. That the speed is your slope. It's also known as a rate of change. So the rate of change is you're changing 35 miles in 1 hour. Now, if you go for only a half an hour, you're not going to go 35 miles. You're going to go half of 35 miles if you're driving for a half an hour at 35 miles. So that's that relationship between one quantity and another quantity. The change in y divided by the change in x. And we can see that in this mathy form, the change in y divided by the change in x. And sometimes in math class, you'll see your teacher write it as change in y over change in x, and that's okay. The little triangle is it's called a delta, and it just means change in y divided by change in x. And then a lot of times, one of the most common ones you see when you're graphing a line on a grid is you'll see rise over run, and you've probably heard that in a previous math class, but the rise is how much it goes up by, and divided by the run, which is how much it goes over to the right by. And if rise is negative, it goes down, and if run is negative, it goes to the left. It goes the other way than our standard conventions of up and to the right. So when I look at this, when I go back and I look at these two examples, I'm going to start thinking, we're going to talk about starting point and slope. So if I'm talking about starting point, the starting point is the output value, the y value, when the x value is 0. So for this is my starting point, because it is the y value when the x value is 0. So my starting point is 8. In this other graph, you'll notice that 10 is my starting value, because it is the y value when my x value is 0. And both of these functions, these are different numbers than the previous one. Both of these are linear, and we can tell because they have a constant input-output relationship. The x is increasing by 1, the y is decreasing by 1. The x is increasing by 1, the y is decreasing by 1. And I can show this relationship at every step of the way. My x is increasing by 1, my y is decreasing by 1. My x is increasing by 1. So if I thought about the slope, or the m, the slope, what is my change in y over my change in x? Well, for this green problem, my change in y is -1, so my change in y over change in x is -1 over 1. And this is just a fraction that we can simplify into a whole number of -1 divided by 1 is -1. So my slope for this is -1. If I were to repeat the process for this red function, I would need to first think about my change in y versus change in x. So I'm making sure that it's linear first before I do all this work. So +1, +1, +1, +1, and this goes up by 5, +5, +5, +5. So my change in y over change in x, my change in y is 5, my change in x is 1, 5 divided by 1, my slope is 5. So my slope is 5, and my starting point is 10, because it's where I started 0. So we've got starting point, and we've got rate of change or slope. Rate of change and slope mean the same thing. So I'll summarize this at the bottom. The start for the green function is at 8, and the slope is -1. Again, on this red one, the start is at 10, and my slope is +5. So we first want to try a problem, and I'm going to ask you to pause the video and answer these 3 questions. Is this function linear? What is the slope? And what is the starting point? So please pause the video. At this point, you should have answered these questions. Let's take a look. Now, if I'm thinking about, is this linear, I want to check as many of these as I possibly can. And there are some tricky ones. I notice -2 to 0 is +2. 0 to 2 is +2. +2. +2. Okay, all of these seem to be +2, but that doesn't make it linear. It's got to be consistent adding or subtracting of a linear function on the right side. So my change in y, if I think, okay, how is the right side changing, and is it changing consistently? 3 to 6 is +3. 6 plus 3 is 9. Okay, this is starting to look, but I've got to check it all. 15 plus 3 is 18. 18 plus 3 is 21. Yes, this is linear because it's consistent x and y. Now, here's something that some people kind of fret over. What happens if I go up by 1, if my increase is by 1, well, if I go up by 3, that would be a problem. So I have to go up by half of what I went up before. So if I go up by 1.5, this still makes it linear, 22.5. It's still linear because the relationship between the change in the y, the ratio of change in y to change in x is consistent. So my slope here is my change in y divided by my change in x. So what was my change in y? My change in y was 3. My change in x was 2, positive 2. And we could convert that into a decimal if we wanted to, or we could leave it as an improper fraction. For algebra, it's typically okay to leave it as an improper fraction, but we never want to use a mixed fraction. That gets confusing. So 3 over 2, or we could do 1.5 over 1, reduce that fraction even though it's a decimal, or that's 1.5. So all three of these are acceptable slopes. If I'm thinking about my starting point, I'm looking for the y value when the x value is 0. And that here in this problem is 6. So my starting point, we're going to call that b. My starting point is 6 because it's the y value when my x value is 0. We'll try one more problem. So pause the video again and I want you to try this one. Is it linear? And what is the slope? And what is the starting point? This is a much trickier problem because we have some missing x values and a missing y value. So try and decide how you're going to think about this and then restart the video when you want to go. All right, hopefully you've had a chance to start this. I'm going to try two things. I notice that I have full values here, here, and here, which will let me determine whether or not it is linear based on the information that I see. So first off, I'm going to check what's my change in y between 1 and 3. It's plus 2. And what is my change in x? 7 plus 8 is 7 plus 8 is 15. And then I'm going to check again. If I go plus 2, does this go plus 8? Is 15 plus 8 23? 15, 16, 17, 18, 19, 20, 21, 22, 23. Yes, this looks to be consistent. And we can pick x values that will make it consistent. So first off, what is the slope? The slope is the change in y over change in x is... the change in y is 8. The change in x is 2. This is a fraction that could be reduced to 4 over 1 or just 4. 4 over 1 means the change in y is 4 when the change in x is 1. So if I go back and I start thinking, oh, what's between 1 and 3? Well, it's 2. So the change in x is 1. When the change in x is 1, the change in y is 4. Is that consistent? 7 plus 4 happens to be 11. Okay, and we can kind of go backwards too. If it goes backwards by 4, it should go backwards by 1. And that makes sense. So 0, 3. And we can repeat this. So if it goes up by 1, it goes up by 4. So 15 plus 4 is 19. And if this goes up by 4, then this has to go up by 1. So 6. And in this process of completing this table, I got my starting point. My starting point is 3 because that's the y value when the x value is 0. So my starting point here is 3. And we could have used, for my slope, if I'm thinking about my slope, we used 4 over 1 a lot, but I could have used 8 over 2 if I really wanted to. Go backwards 2, so subtract 2 and subtract 8. And so we can think about it either as the reduced form or the unreduced form. Both are actually okay. All right, we're going to start thinking about word problems. So I'll read this out loud, and then I want you to make this a T-chart for this information. 3 friends worked on Saturday. John worked for 6 hours and made $54. Sally worked for 8 hours and made $60. And Charlie worked for 5 hours and made $50. How much money do they make per hour? And make a T-chart with this information. So I'm just going to go ahead and get started, and hopefully you've already done it or you're going to do it with me. And I'm going to try and do it in number order. So I want to think about 5 hours first, and 5 hours is $50. And 6 hours is $4, and 8 hours is $60. Well, I noticed that I skipped 7, and so 7 is a value in this T-chart that I could potentially figure out. I'm assuming that it's linear, and let's find the slope. So I'm thinking about slope. We call that m a lot of times, so m is the slope. And the slope we know is change in y over change in x. What is the change in y? Well, y is now the dollar value, and x is the hours or time. So my change in y is plus 4. My change in x is plus 1. So my slope for this is $4 in 1 hour. So hey, we figured out how much they made per hour, $4 per hour. And we can actually figure out what 7 is, if I wanted to. Just notice that $4 per hour, 4 over 1, is a fraction, and it's also equivalent to 8 over 2, just like the last problem. So if my x value goes up by 2, like it does from 6 to 8, my y value should go up by 8, and 54 plus 8 happens to be 60. If I wanted to figure out 7, that's an increase in 1. So an increase in 1 means an increase in 4, so 58. So plus 4. And it's consistent. Everything with linear is the same ratio of y to x every time being added or subtracted. Right, another one. This is a little tricky, so I've started to fill out the T-chart for you. 2 days ago, I had $20. I started selling candy bars, and I made $3 each day. Make a T-chart with this information. Okay, so we started the T-chart. How much money will you have on 3 days from now? So my rate of change, my slope, I'm even told my slope is $3 each day. So my slope, my change in y, is $3. My change in x is 1 day. So my slope is 3 over 1. So I increase by 1. My x increases by 1. That means my y increases by 3. So on day -1, or the day before today, I had $23. And today I have $26 because of plus 3. My change in y is plus 3. My change in x is plus 1. I add 1. If I wanted to skip this altogether and just go from day 0 to day 3, that would be a change in x of plus 3. But notice, my change in x doesn't come in plus 3, but 3 over 1 is equivalent to 9 over 3. The fractions are equivalent. And this comes back, I know that we don't always like fractions, but in this case it's really helpful. So my change in x is 3, like it is over here. My change in y is 9. So from 26 to 3 plus 9. When my change in x is 3, my change in y is 9, so 26 plus 9 ends up being $35, and that's how much money I have today. I didn't even need to do the plus 3, plus 3, plus 3, and this can be really helpful sometimes. And even though this is a simple example, this complicated explanation of making my fraction bigger is helpful. All right, last but not least is to understand how slope relates to graphs. And so slope, remember, is the change in y over the change in x. It's also known as the rise over run, but I really like this understanding because it requires us to be really thoughtful every time we make the graph. So if I draw a line that has a slope of -3 over 4 that passes through the point -5, 6, I first am going to start at -5, 6. And when I start at -5, 6, remember that x, y is how my numbers in a ordered pair go. So I'm going to start at -5, 6. So I start negative 5 over to the x, and then 6 is my y value. So I'm going to plot a point right there. Oh, started at the wrong spot. Negative 5, 6. And my change in y over change in x is negative 3 over 4. So my change in y is negative 3. My change in x is 4. Now you're probably wondering, how come I put the negative part on the top of the fraction? How come I put the negative? I typically like to put it on the top of the fraction. You can choose. It could be one or the other. So if I think about my change in y being negative 3, my y value is up and down. So change in y is down 3, or negative 3. 1, 2, 3. And my change in x is 4. 1, 2, 3, 4. And we get to put a little dot here at this new point. So change 1, 2, 3 in the x direction. 1, 2, 3, 4 in the y direction. Plot a new point. And I can actually repeat that. Change in x is down 3. 1, 2, 3, minus 3. There's my minus 3. And my change in x is plus 4. 1, 2, 3, 4. A new point right there. Plus 4. Plus 4 in the x direction. And once I do this a few times, I can repeat the process. So I go down 3. 1, 2, 3. And over 4. 1, 2, 3, 4. And I can start plotting all the points on this graph. And once I've got enough points to kind of see how to graph it, I can use a ruler and connect all the dots. And that's a line that has a slope of negative 3, 4 that passes through the point negative 5, 6. Negative 5, 6 is the point over here. All right, please pause the video. This is also on page 7 if you're working in your workbook. But take a moment to find the slope of all of these lines. We'll do the first one together, the purple line, and then I'm going to have you do line 2, 3, 4, 5, and 6 on your own. So I look at this line and I see I'm going to try and make a triangle because that will help me. And I could have chosen that triangle, or I could have chosen that triangle, or there's a giant triangle here that I could have chosen, and I'll do it in blue so that you can see the difference between my triangles. But this giant triangle, all three are going to give me the same results. So if I think about it from a change in y over a change in x, because that's what slope is, my change in x is 3 because it's going over by 3, and my change in y is 2 because it's going up 2. So my change in y over change in x is 2 over 3. Now when I drew the big triangle, and I'll draw the big triangle again here in red, the big triangle went over way more and down way more. But notice, take a look, that the big triangle has a change in x of, instead of 3, it's changing by 6. So this is my change in x is 6, my change in y is now 4. Oh my goodness. And my change in x is 6, my change in y is 4. My change in y is 4 over 6. Hey, 4/6 is the same as 2/3. It's just a reduced fraction. 2/3 is just a reduced fraction. So what I'm going to do is I'm going to erase the triangle on the grid, and I want you to try to determine the values for all of these examples. When you're done, I'll count down to 3 and I'll show you the answers for each of them. All right, the answer is coming in 3, 2, 1. Here they are. All right, so here's the hard one. The two hard ones are the red line and the yellow line. So notice that the red line, there is no change in y. And so that's why the change in y on the top is 0. So there's no change in y, there's only change in x. Whereas the yellow line only has change in y, but no change in x. So I said it went up by 1, but if you chose like 4, and 1. And typically, we call this undefined. And when a line goes straight up and down, it's always undefined. That's a special note that you probably didn't know, but anytime a line goes straight up and down, it is undefined. All right, if you have your workbook, please do problems 9 and 10 on, pages 9 and 10. They're really meant to help you understand slope as it relates to the graphs. This is a good time to practice understanding slope and rate of change. The really important things that you need to know is rate of change is change in y over change in x, and that's also called slope. We call that m. All of these, this idea of rate of change has like 4 different ways of saying rate of change. Thanks for watching the video. I hope it was helpful. We'll see you next time.